Okay, so today this is the second session regarding the deep program extra, a session that we are planning to cover regarding Arduinos and 3D printing and circuit making, those kind of extra sessions that we were planning from the beginning. And right now we are going to start the second session that we planned, that's the introduction to Arduino. And for the first session, we talked about the introduction to embedded systems. And then this is the second part. That and as like before, we have our resource person, Mr. Saliya from Sri Lanka, joining with us to share his knowledge and his wisdom regarding these topics. So, Saliya, the floor is yours.
Uh, so as Mr. Ajamitra mentioned, we have already talked about electronics and embedded systems. Today we're going to look about Arduino. So we're going to take a introduction to Arduino today. So Arduino is a platform that have two sides. It's one software, other side is hardware. Let's see what is Arduino in a little deeper.
Hold on. Okay. Can you go one slide before, please?
Yeah. Oh, this is the today, right?
Can you quickly tell us the layout?
Yeah, we're going to look at what is Arduino. Then we're going to talk about its software and then hardware. Then we're going to look at non-binary signals. Then pulse width modulation, the PWM. Then analog read and write. Then functions. Then interrupts. Then logic level voltage, and then variables. Okay. So the Arduino is a open source programmable circuit board based on a microcontroller, and the both software and hardware also open source. You can go to this website and find more about it. And the programming language that used to program the board is called Sketch. It's like a simplified C language. Sketch is an easy to learn human readable programming language. It's not like C or C++. This Sketch language is real easy to learn, right? And there are these boards you can see contain almost every board contains Atmel processor. This green color, and the Atmel processor is some kind of like you can easily identify these boards are from the original manufacturer. The original boards also contain this Arduino name in front of the board. Like this says Arduino Uno. Next one they say Arduino Mega, and Arduino. This is this one here, this blue color little one. This one called Arduino Pro Mini. This is Arduino Leonardo. This is Arduino Do, like so.
Nice. Sally, can I ask a question?
Yeah.
So you're saying for each of these circuits, they're using Atmel.
Yeah, this processor is Atmel one, and then these original boards, most of them are designed based on these Atmel chips.
Okay.
There are other boards that different. They contain different kind of chips. Those chips are from different manufacturers. This Mega, Uno, Pro Mini, or Leonardo. These boards contains AVR microcontroller, which is manufactured by Atmel company. Yeah.
Is this okay? We just set me down real quick?
Yeah, sorry, you can go.
Okay, we'll just set down.
Now we're going to talk about Arduino software. This is the Arduino program structure. When you open the IDE, it will load something like this. Basic program look like this. It will contain void setup and void loop code
You're using void code
by default.
to people like Signal? Yeah, because
This void setup here, you will have
photodiode or
your
photoresistor?
codes that you want to run only once when the system boots. Code here get executed only once. Then you come to the loop.
Personally,
You can
I would
write here
recommend,
your program logic,
using a
which is
or
which
a,
will run repeatedly
photodiode over
until board gets shut
That
down.
might be a photoresistor, but a photodiode.
So sorry, one question.
Could take the signal.
So you're saying in void setup, you just
Very well.
that's where you start your coding, right?
I'm just thinking of
Yeah.
And sometimes I see
Okay.
in some programs they're defining pins before the void setup part. Is there a difference?
Those are
Okay.
variables.
Okay.
Yes,
Then,
those
okay, never mind.
old variables. Okay.
Okay.
We use here to like initialize things. Like this pin is used to earn an output. This other pin used to do input. Like so.
Okay.
Sure, yeah.
Sorry. Let me ask you.
We will
I was just,
do that in
I was
the
just surprised you're.
Yeah.
Okay. Okay. So we'll cover it later. Okay.
Yeah.
The noise is good.
Thank you.
These are different Arduino boards. This is not the the Raspberry Pi
In
Zero.
fact, you were telling me you don't have noise off that.
No, this is a Pico, not Zero. Sorry, this is a STM32 Blue Pill.
But
This
either
is
way, so,
not MCU. This is a ESP32.
yeah,
Sorry.
maybe you could avoid the
Boards
Arduino.
from
If you're
different
trying to show the
manufacturers.
sound signal, you might
They all
honestly
support
even consider
Arduino programming. Just download and install the required libraries to Arduino IDE. Then you can program.
Yeah, I was just thinking maybe it'd just be worth it to attach a phone.
Using the Arduino IDE and the
In the meantime, at least while you work it out, if you want to present that as a special.
STM32 board
Yeah, that might be.
has its own IDE.
For this,
You
you
can
don't connect
download it
to.
from their website. It supports lots of boards, and the other boards you can program with different IDEs. Anything that supports C or C++ assembly, like so. The Arduino supports all of these boards with libraries installed. Right. Then we come to industrial controllers like PLC, programmable logic controllers. Now Arduino for softwares and hardwares for PLC as well. These PLCs are used in road traffic signals, automated car washes, elevators, automatic doors, conveyor belts, roller coasters, and nuclear reactors. And if you have heard about Stuxnet, it's a malware that targeted PLC hardware to some, I guess, sabotage a nuclear program, right? It's good to know about these kind of things that when it comes to security about these hardware and softwares. So anyway, now Arduino started as a hobby level platform. Now it has grown to industrial controllers, right? Now this is when it comes to PLC, we do not use codes very much. It comes with a visual programming interface that for some kind of a logic blocks that you can connect together and build the code. And there's a visual Visuino IDE that you can do the same with any Arduino board. Just using logic blocks, you can develop your code and upload it to Arduino board. So you don't have to know anything about C, assembly, or sketch. Just have to build the logic using these visual components. It will generate the code. So it's very easy to use. Now we have come to Arduino hardware. Any questions you want to ask?
Exact same thing.
I think we can go ahead.
Okay, right.
They're seeing the same.
Now, if we look at the Arduino Uno, Now you can see it contains Atmega 3228P processor, which has EEPROM of 1 kilobyte, 1 kilobits. Okay, so external power connector. Okay, right.
Sorry, you can go ahead.
Right. If you look at the Arduino Uno hardware layout, it contains a Atmega 328P processor with EEPROM of 1 kilobits with an external power connector with USB-B port. Sorry, and clock speed of this board is 16 megahertz. It has a digital I/O pins, 14 of them, analog input pins here, 6 of them, and PWM capable pins, 6 of PWM capable pins. If you can see this little chip here, can you see?
Yeah, you can see it.
Yeah, this chip is the one that responsible for handling this USB data. Okay, this like there's a when you connect this to the computer, there's a virtual serial port get built in the computer, and that communicate through this chip. Then this one here is the main processor. We upload our code to this processor. Okay, this is the one that runs our code. This one just only here for take care of the communication part of the board and the host computer. And this, you can see this pins here, this IC SP pin. This is used to program these chips using a different programmer. If you have a yeah, this one here, and this one here. These are used to program these chips separately using a different programmer, which means this you don't want this board anymore, so you can just plug in different kind of a programmer and program that chip through that programmer. Okay, right. So
Sorry, can I ask a question?
yeah.
Is it something like what kind of a external program you are talking about here?
There are many of them. One is AVR Dragon. We usually use USB called USB ASP. Okay. Yeah, this is the one we use. This is inexpensive. Available program. So
So
another one, this chip here, this contains something called a bootloader. Okay. This bootloader is the one that add the capability to this board that can be programmed through a computer, that so that you don't want to have a dedicated programmer to program this chip. So without bootloader, you can't do this. You can't program this through the USB, which means that let's say you buy one of these chips, blank chips from some Amazon or eBay, it does not contain bootloader, then you have to use a separate programmer first to bootload this IC. Then you can use that IC in this board, so you can just go and plug into the computer and program it. Is that clear, Ajit?
oh yeah, that's really informative. Yep.
Okay. Okay, this you can see this board have a 5-volt output and 3-volt 3 output as well, and the ground pin is here. It's when you working with these boards, make sure this you don't short circuit this ground with 5 volts or the ground with 3.3 volts. This will damage the entire Arduino board. Okay, that's important to remember. Yeah.
So technically, you said if this 80 mega microcontroller get damaged, we can swap it if we want,
Yes.
right?
That's another important thing about this model of the Arduino board. You can easily
Okay.
remove this chip and replace it with another chip.
But
So
you're saying, sorry,
yeah,
even if you replace it, first you have to upload the bootloader
yes,
externally and then use it in Arduino.
yes.
So,
First, you
so
need to bootload this chip using a different programmer. But nowadays, you can buy bootloaded chips also. It means that it comes with the bootloader. Just have to plug and play like so.
awesome. That's first time I heard it.
Yeah, yeah. Okay, let's move to the next one. Right? All right. Now, if we talk about why digital and analog pins, digital pins only output ones and zeros. It means like on and off. So if we want something like in between, like let's say you want to dim a light, something like that, then you will have to use analog pins. It means like digital pins only output something like this. It means like 0 and 1. Right? So if you use analog ones, it can output something like this waveforms. Means like 0.2, 0.3, like so.
So technically, it's like for digital, you have a binary output. You can have
Yes,
either
yes,
on or
yes,
off. That's
yes,
you have just two options, right?
yes,
It's
yes,
like flipping a coin. But in analog, you can have any value from on to off, any value up to
yes,
that level, right? Nice.
exactly,
Okay.
yes.
Awesome.
Uh, okay, right.
Nice.
Now we come to the digital and analog signals. We're going to talk about digital and analog signals. Ajit, will you explain this a little bit?
Nice. So it's like this, right? So what you mentioned earlier, we have digital and analog. So how are these happening in real, in practical level? So we have two kind of main things in when it comes to electronics and Arduino, some one called sensors and one called actuators. Sensors grab something from the output, sorry, from the environment and put out a data. So actuators completely do the opposite. It takes something and then give to the output. No. So we have two kind of things. We have sensors and actuators. Sensors basically sense what's happening in the environment and then turn that into electrical signal. Actuators completely do the opposite. It turns electrical signals to something practical, to the environment. So as Sali mentioned beforehand, we have two kind of things called digital and analog. For digital, you have so you can have like binary output. You can have either on or off, and same thing you can have with sensors and actuators. So in the first row, we can see in sensors we can see a button right in the middle, and then on the left you can see a LDR. It detects the luminosity, right? And then third one you can see it's a motion sensor. So it's if you have someone, it's on. If you don't have someone, just it's off. So same with the actuators, right? So we can turn this LED on or off. So it's just that on or off. So same with the motor, you can turn it on or off. But you can use the same idea for the analog. So let me take the same example as the LED. So you can have in the digital case, you can have it on or off. But in analog case, you can make it dim or just vary that intensity of the LED. So that's where the analog idea comes in. So you can have any value between 0 and 1. So it's really easy to understand with the LED idea. And then when it
So
comes to motor,
yeah, you can use the analog signal to control the speed of the motor, right?
exactly,
Yeah.
exactly. So like change the speed, exactly. So in the sensors, analog, in that section, you can see we have potentiometer. We can rotate and then get some kind of a value in between some 0 and 1 kind of value. And then third one using ultrasonic distance sensor and then temperature sensor and the force sensor. All of these will give you a value between 0 and 1. I think that's the main idea here, right?
Okay, right. Let's move on to the next slide, right?
Mhm.
Yeah, okay. Then we come to this, which means that okay. So the Arduino board only have has many digital outputs. Okay, then so we have to find a way to use these signal binary signals, way to convert these into analog signals. Sometimes when we need to use analog signals, most popular way is to use a signal generator like this. This chip can be connected to Arduino, and you can control this board through the Arduino board. So this board is the one responsible for generating output waveforms. So this can generate like sine waves, square waves, triangle, sawtooth, like so. Yeah.
So sorry, let me ask this. So
Yeah.
this programmable signal generator. So you
Uh,
are,
yeah.
it's like it's like a bridge that you use from Arduino, correct?
Yes. Like this board can't operate standalone. It means like this one needs to be connected to microcontroller. Okay. So you have
Nice.
to tell this board uh, generate this kind of waveform. The instructions needs to be sent to this board to generate that. So the instructions we send to this board is binary, and the output of this board is analog.
Let me ask this.
Yeah.
So still from this signal generator, you're getting an analog one, right?
Yeah.
So is it like completely like a pure analog signal, or
Yes.
is it like that?
This is like you can generate pure sine signals from this board. This board is very important because of that. We can't Arduino has analog. There's PWM cable pins that can write signals like that, but they are not very clear, right? We can't generate pure sine wave from Arduino. It's hard, and it's not like it's not pure science. If you connect it to the let's say oscilloscope and zoom in, that you can see there are some noise in there, right? It's not pure sine, but it's good for some purposes. But when it comes to something like you want pure sine wave or sawtooth, we use something like this module. It's dedicated to generate those signals. It's clear.
Awesome. Okay.
Okay,
Yeah,
right.
it's a new, really
Yeah.
brand new information I heard.
Okay. The other way is to that if you want to generate a sine wave or something like other analog waveform, you can use something like a lookup table. Ajit, can you explain this a little bit?
Yeah, I think what's happening in here is so you first of all you see this byte BYTE term, right? So
Yeah.
that's where you have 0 to 256 of bins
Yeah.
basically, right? And here you are dividing it into to some sections. In this case, it's like you can see 0, 4, 8, 3. So you have like these values between 0 and 255. And in the right part, we can see the sinusoidal wave in the blue color, and then this other curve with the red one, and it's saying PWM. I think we're going to talk in depth about that in a minute. So what's really happening here is we are creating the sinusoidal wave by using just PWM signals. I think I'm correct, right?
Yes. So we
Nice.
turning on and off the pin. So it will generate the sinusoidal form or waveform. It's like this, that pin will be on and off according to this shape, right?
Yeah, exactly. And right now on this table, we are seeing what's happening from 0 to 90 degrees. In 90 degrees, that means where we get from the middle point to the first maximum of the sinusoidal wave, which is 1. Yeah, exactly what you're showing by the cursor. Saliya?
Okay, right. This is example code from the internet. I haven't tested it, but if you can run this in Arduino, you will get output of sine wave from its pin level. You can connect this to a oscilloscope and check how it goes. Right? Do we have a
Awesome,
system?
awesome. Right now we don't.
Okay, right.
We're planning for that. So let me bring a really good question at this point, Sari. So here you're showing,
right.
yeah,
We see, right. Nice.
exactly.
Right.
And so at this point, let me ask a really good question, because from the things you share. So to make a sinusoidal wave, we have two options. You're showing
Yes.
one method here.
Yes.
So the PWM signal, and then earlier you showed
Yes.
something called a signal generator, external attachment. But external attachment, that method is more pure than this method. Right?
Yeah. It is like that board contains a dedicated processor and crystal to do just that. So you don't have to sacrifice your Arduino's processing power to just to make this sinusoidal wave. And
Awesome.
it's that the external module is very capable of generating just waveforms. Yeah.
Awesome. Thank you.
So now we're going to talk about PWM. PWM stands for pulse width modulation. So the PWM is a technique for getting analog results with digital means. It means that you can generate analog you can generate analog waveforms from digital signal. So the main purpose of PWM is to generate variable voltage supplies with minimal power losses, which is considered to be the most effective way to regulate voltages. So in PWM, we simply turn on and off our power supply at equal intervals and thus reduce the average power of the signal. Sorry. Okay, right. So PWM signal will look like something like this. So according to this, the analog signal will be generated. Why this getting fade off?
I don't know, but it looks like a really good thing, right?
Vanishing pin. Okay.
It looks really neat.
Wait, I have to find the. Right.
It's a vanishing line.
Okay. Now, if we look at these picture here, you can see there's a 5-volt power supply in figure A, right? As shown in the below figure A, I have taken a 5-volt DC signal and divided into 3 equal intervals. Each interval will represent one cycle. So this part is one cycle, right? Isn't it? PWM.
නෑ නෑ පුළන ඒ ටිකයි කිව්වා. ඔතන මේ ෆිගර් A එකේ කියන්නේ ඒ අර බින්ස් තුනක් වගේ කඩලා තියෙන ඒක ගැන.
මේකනේ.
නෑ උඩ එක. ෆිගර් A. ඒක බලමු.
මේ
අන්න අර. ඒක පෙන්නපා ඊට පස්සේ ස්ටෙප් බයි ස්ටෙප් එක. එල ආගම්.
So if you can see the picture here in the A figure A, we going to talk about figure A as shown in the below figure A, 5-volt DC signal, and we have taken 5-volt DC signal and divided into 3 equal intervals. Each interval representing one cycle, like so. In the in figure B, for each cycle, the power is on for the first half, while it's off for the second half. Yeah, here on then off, on then off, on off, like so. This fast switching of the electrical signal will reduce its average power, but the output will remain continuous, and for the 50% on off cycle, the output of 5-volt signal will be around 2.5 volt as shown in the figure C. If we have 5 volt signal and we apply 50% duty cycle, it will give us 2.5 volt output, like so. And this here you can see, like if the signal is like this, and if it's like this, like this width of this here and this pulse will determine the voltage. Like if this is wider, it will give us higher voltages. If it comes to smaller width, it will give us smaller voltages. This figure C here, Ajivitra, it's clear to this because I had some hard time understanding how it worked. Finally, I got it. But yeah, can you understand that this like this width here responsible for have that voltage?
Yeah, I think, but in here, okay. Now it's a bit confusing to me too, because here first we thought we have only two beams, right?
Yeah.
Oh, sorry, only 3 beams. But in here, is it 50-50? It's not 50-50 now, right?
Yeah, like it's 50-50 is like every square is like equals, right? But
yeah.
if you do something like this, it's like 25% or something like that, right?
But the period, it changes then, right?
Yeah. So I think this width is responsible for generating the voltage, right? Like if you turn this on for like longer, the voltage rise something like voltage rise to some like what to say, like let's say this is 5 and 0 and 5. If we keep this on for a little while, this will rise to 5. if we keep like this width, it will only like rise to like 2.5, something like that, right? Do you understand what I'm saying?
Sally, can I ask something here?
Yeah.
I think it's better if I draw this because how can we draw here? Whiteboard? No, not
I think.
whiteboard.
Yeah.
How do you draw here? How did you get there? Even I. Yeah, seriously, how do you do that? Oh, there's a more
I know it.
annotation. Okay. This guy, right? Tell me what's the main difference between this and this one. So let's say you have this. You have this kind of one, and I'm starting here at 0, right? So let's say I'm turning it for 50%, right? And then I'm closing it here. But right now the period is this value. Let's say this is the period, right? So what's the difference between this and this? I'm taking the same period. This is why we should have a.
Sorry. I cleared yours as well, right?
Yeah, maybe let's try this. I
Oh.
think this is better. This is better. Right? Let me. I think what you did accidentally is better, right?
Yeah.
So let me draw two things with the
Yeah.
same period and then ask you this question. Right? Yeah, I think I can straight up this. Okay. So let's say I'm switching it on at start, and then I'm gonna keep it like this, and then switch it off, and then bam, switch it off like this. So in this case, it's gonna switch on here, but it's the same idea. So we have the period from here to here. Right? So we have 0, and then it's ending here. So this value is 50%, right? 50%. So let me draw this, and can you tell me what's the difference? I'm going to switch it on, keep it for 25%,
Yeah.
and doing this, and I'm getting 2 times the period that I had. Is this the same result, or is it a different result?
This is like if we talking about 5 volts. Let's see if we apply this 50% to 5 volt.
Okay.
You will get 2.5 volts, right?
Okay.
So now if we here like let's say 25%, you'll get 25% of the 5 volts.
But in this case, we have the same period.
Yeah, that's what I'm trying to tell you. But this
Okay.
this width here is different, right?
Okay.
So it means that we kept our power supply on for little longer than here, right?
Okay.
So the output will be less in here in this case. In this case, output will be little higher.
So it's
yeah.
no, you exactly like you really you explained it really well. So the amount of time that we keep it on, that determines the output straight up.
Right.
Got it.
මට මේක තේරුම් ගන්න මේ සෑහෙන වෙලාවක් කියනකොට ඒ කියන්නේ මේ දැන් මේකේ මේ දැන් මෙතන තියෙනවනේ 2.5 ලයින් එක.
හරි.
මේ සිග්නල් එක උඩට තියෙන්නේ බා.
හරි.
ඒක පහේ තියෙන්නේ.
හරි.
මේ එතකොට මේ මොම්බල දැන් මේක පහනම් තියෙන්නේ කොහොමද මෙතන 2.5 කියලා. එතකොට මේ ඒක ටිකක් කළා බලගෙනනකොට තමයි තේරුනේ මේ මේක පහටම නගිනවා මම කියන්නේ මේ සිග්නල් එක 2.5න් නවතින්නේ නැහැ. තේරුණාද?
අන්න හරි ඒක එළනේ පොයින්ට් එක.
කතා වෙලදී මේක කොහොමද පහටම යනවා ඒක කොච්චර වෙලා පහේ තියනවද කියන එක උඩ තමයි මේක 2.5 එතන ඒ ගාන තීරණය වෙන්නේ.
අන්න හරි. මේ ඔය පොයින්ට් එක එළම තනක් සෙට් වෙනවා. දැන් එහෙම වුණොත් මේ දැන් ලේසියක් වගේ on කරන්න PWM එක තමයි හොඳම ක්‍රමය බා. එතෙන් ගිහලා
ඒක අර voltage එක ලස්සනට තියාගන්න පුළුවන් නේ.
අන්න අර උඩට වෙලානේ. ඒක කියන්නේ සිරා පොයින්ට් එක බා. nice nice.
So
ඒක දෙන්නම ඉගෙන ගත්තල පොයින්ට් එක ඈ.
so okay, we move on to the next one, right? Yes,
I'll remove those erasing time.
so right, we can go to. Did we miss something?
No. You,
So, okay, cool, okay, right. Okay, when it comes to the Arduino analog, do we have to go to this and explain it?
yeah, it's at least show it. Mhm.
Okay. Can you see the?
Yes, it's visible. Mhm.
You can see this website, right?
Yes, it's visible.
Okay, right. So basics of pulse width modulation. So there's a, let's say, yeah. You can come to this site and read more about PWM, and there's a graph explaining how this PWM and duty cycle works when you use analog write function right here, right? You can actually try some codes from the site like this to see how it operates when it upload into the Arduino board. Okay, this is only basics, and if we switch back to this, then if we talk about advanced PWM topics, there are two things you need to know. The fast PWM, it means like this. Fast PWM like this. It counts from 0 to 255 like this. Then it goes here down. Then again it count from 0 to 255. Then goes down like so. This one is called fast PWM, right? The other one is phase correct PWM. It's like it works like this. Like it count from 0 to 255. Then again it counts from 255 to 0. So these like both slopes are equal, like so. This mode is called phase correct. So the Arduino IDE does not, the Arduino framework does not provide way to achieve this. Then you will have to use CU assembly to use these features. These are advanced features if you want to build some precise, let's say precision waveforms. You will have to use these functions, right? Although there are some libraries that you can come near to generate some waveforms like this, but it's not giving all the access to generating these kind of waveforms. Okay, right.
Sally, can I ask something? So for the fast and phase correct,
Yeah.
It's kind of like you have a continuous, like an analog signal already, right? Because you have this slanted power supply.
Yeah,
Slanted signal already.
yeah, this is like these are timers. Okay, like this timer counts to 0 from 0 to 255, then it goes down. It's like it's like a stopwatch, you know. It's
Okay.
just from 0 to 255, then again it reset, then again 0 to 255. So if you connect this to a output pin and to a oscilloscope, you will see this happening. Goes up and down like a triangle waveform. You can see in the oscilloscope.
Got it. Mhm.
Okay. So, for example, you can use a built-in LED of the Arduino Uno to see how PWM function work. You can vary the brightness of that LED connected to the pin 13. I remember. So you can see if you write like say 100. If you write analog write 100, it will the LED will light up like I think we will better explain this in the practical session, right?
Yeah, I think it will be easy.
Yeah, yeah, right. 100 like 127. If you write 127, it will turn on 50% of the LED. If you write 255, it will give you the 100% of the brightness. Like so, you can dim the LED with analog right. Also, you can control speed of the DC motor. Okay.
Sorry, can I ask something? So in here we are using Arduino digital pin
Yeah.
to make an analog signal, correct? So this is where we use PWM.
Yes.
We are making a signal.
But
Right?
remember, this chip has some pins that they are capable of writing analog signals. Okay, if you read the data sheet, these there are some pins that they are like you don't have to code them. Do this like you don't have to say like how to write analog output to this pin. They default by default they know how to do that, right? Like only few pins
Awesome.
can do that, right?
Awesome.
You can use those pins to write like PWM signals.
And those are the pins with this small tilde sign.
Right. Yes. Right, yes. It's like,
And at the digital pin set, right?
yeah, yeah.
Awesome. Let me ask this.
Yeah.
So you said it's from 0 to 255, right? So we had 256, like a byte,
Oh,
to the 8
you see,
value. So
0 to 255, okay, not 256, right?
nice. So including 0, we have
Yes,
256
exactly. Yes.
bins, right? Thank you. And so this means this is the hardwired, or this is like physically constructed like that, right?
Yes, yes.
And this is what we call
Only
digital to analog converter, like DAC value resolution. Am I
yes,
correct?
yes. It's like that we have like 8 boxes. These boxes only can be arranged in a different phase, like only 255 different phase, 256 different phase, right? I mean, I think you can
Awesome.
explain this better, like with maths, right?
Yeah, but I think you explained it perfectly well. Yeah.
Oh, right.
Nice, nice.
Right. Okay. We want to look at analog read. Now, if we talk about analog read, that sometimes we will have to read signals from the outside world into the microprocessor. So this is called DAC, means it stands for digital to analog. Then now we need something analog signals, okay, coming inside to the processor. So it's like ADC. We call this ADC, analog to digital conversion. So there are some part inside the microprocessor called ADC. When you input, like we say, we input 5-volt analog signal to this will set some bits in inside microprocessor, right? So now you can read these bits and convert into a voltage inside the microprocessor. It's like let's see, we read 5 volt here, it will set some bits like this. It's not exactly the value, but you can read this binary and convert it into a voltage using the code. That's what ADC does, right? So reads value from a specific analog pin. Arduino would contain multi-channel 10-bit analog converter. It means that that box have bit 10 bits. So you can arrange. So you will have like 24 bits. 1024 arrangements you can have with this. It means that resolution, right? It means that if you want better resolution, you will have to use like 12-bit, 16-bit, like that.
So what's the maximum ADC resolution of Arduino board that out there?
Most boards contain those little chips with, I believe they like 8-pin ones you can see in the market. They probably have 8-bit or 10 bits. There are new boards that little expensive. The one we used in our magnet project. Yes,
I think we used an Arduino DUE board, right?
Mm-hmm. Yeah, that thing contains 12 bits, right? If now there are like external modules that they can read like 16-bit 16-bit ADC, or maybe there are some chips that read more of these and convert it to a readable that Arduino can read that signal from these modules. So the Arduino board can't directly read like 16 bits, but you can use external module to do that, and like Arduino board can request that data from this module. Clear?
Yeah, but maybe let me ask you this question at the same time.
Yeah.
So in Arduino, let's say 10-bit one, so it has that bins only. So let's say we connected what you just said, external one with 12-bit.
Yeah.
But whatever it can measure, it's not enough for Arduino to read. So how that conversion happens?
Like that stuff will be happen inside the module, I believe. Then it will send the data, right? That conversion and everything will happen here. Then it will say, yeah, right, I read 5 volt. Then
okay, so it's like connected hardware wise too, right?
Yeah, yes.
Got it.
Hardware is responsible for measuring and doing all that hard stuff. It just sending Arduino the actual result. Okay, right, I read this much, like so.
Awesome. That's really detailed. Thank you.
Okay. So that's about Arduino analog breath function. Okay, these are the basic functions that you can use in the Arduino sketch program. So pin mode stands for that when we use this microcontroller, you will have to tell it which pin which pin needs to be which like let's say if we want to drive a LED connected to a pin 13, then that pin needs to output a voltage. So we will have to configure that pin as a output. This is the way that you tell the microcontroller, I need this pin to be output. Let's say pin 13, then it's output. When this code runs, it will output 5 volts from that pin, right? If you want to read something from a specific pin, this is the way you tell the microcontroller, I want to read something from this pin. Let's say A2 pin. Okay, now the A2 pin is configured as an input. Then you can apply 5 volts to A2 and write some code, and you can read the value from that pin. Then, sorry, I think may I go?
Hello.
Okay, some other functions. So when you use a microcontroller like this, you will have to give a specific instruction to do what to do with these pins. So let's say if I want to turn on a LED at pin number 13, that you will have to get a output signal from this pin. So you will have to configure this pin as a output pin. Then you connect LED to pin 13. Then you write this code here. It's like pin 13. Turn it on. Like in Arduino, you say digital write high or low. High stands for on, low stands for switch off. So if you write this code and run this code, it will turn on the LED, which means that this pin number 13 will output a 5 volt voltage. If you turn it on off, then it will switch off the that pin. Now let's say if you want to read something from outside world, like 5 volt or something. Let's see, we have analog pin here, like A2, this one here. So now I'm configuring that, like I'm saying the microcontroller that I want to use this A2 pin as a input. Then this code you write inside the setup function. We if you remember earlier, there's something called setup function. Let's see. Here, we write here this. We write that code here. Like we mentioned this. We're going to use this A2 pin as a input. Then we write our reading code here. Is like analog read. We write here because this code, like it runs in a loop that we need it to be running all the time, right? So if we go to right, so here we want to use A2. We'll see this in a practical session. I think it will be more clarifying, right?
Yeah, let's
then
explore in depth.
First we mentioned we're going to use this pin as an input. Then we go read that pin. Then we can use some code to read the input value from this pin. Then also there's an analog write, the analog write function that which we can use PWM pins to output the analog signal. And the serial print is the one way to debug your programs. Like to see what's going inside the microcontroller, you can use this serial print or serial print ln command, right? We'll actually see how to do this in a practical session. I think it will be more clarifying, right? Right.
Absolutely.
Okay, then we come to interrupts. Interrupts are like interrupts are commonly used by hardware devices to indicate electronic or physical state change that require time sensitive attention. So interrupts job is to make sure that processor responds quickly to important events. Let's say, so for example, let's say you build some kind of machine that has to have a emergency stop switch, right? So which means that when you press this, machine needs to be immediately stopped. To do something like that, we will use an interrupt, right? This means that when you press this button, processor stops all other operations and pay attention only to this task, right? Like let's say processor has been counting something while you pressing this emergency stop. Processor is going to hold this operation and pay full attention to that emergency stop event, like so, right? That's the purpose of interrupts. So there are two kind of interrupts: internal and external. Internal interrupts are caused by some events inside the processor. External ones are caused by outside signal. And also there are only if we talk about Arduino Uno, only 2 and 3 pin are digital pin 2 and 3 are the only capable of handling these external interrupts, right? And also that you can detect these states: low, change, rising and falling states. Also the new boards can also detect high as well, high states as well, right? New boards can detect that. All other Arduino boards can detect these 4 states. Now if we look at the signal, you can see here, this is the rising part, this is the falling part, and we call this here rising edge. This one here we call falling edge. So when you can write, if you write the code to change code to detect this, like when signal arrives here, processor will give you a processor will tell you that, okay, right, I have detected that rising edge, that tell me what you want to do with that, okay, like so, right? This is how you use interrupts. This is the recommended way. There's another way to do this, but in Arduino, this is the recommended way. Attach interrupt, digital pin to interrupt. Like let's see, I'm using digital pin 2, and this is the function that needs to be executed when you detect this interrupt, right? This is configured to detect change. It means like rising or falling edge. One of these event happens, this interrupt will be triggered. When this interrupt triggered, this blink function here, this will get executed, like so. And also remember that if you're using interrupts, do not use delay functions inside this, okay? This if you somehow want to use delays, like use it in a different method, not inside this, right? Like it's good to use this interrupt detect and its functions, like to set a flag. Let's say we have a Boolean flag. Then this when this interrupt happens, we register this flag is true, right? Then somewhere else we use check this, if this flag is set, do this, like so, right? We like state machine, like we only use this to set check the state and set a variable. Then so the processor won't hold at unnecessary points, right? Like so. Right.
Nice. Mhm.
So that's about interrupts. Then we will have to, sometimes we will have to use different boards. Like some boards operates at 5 volts, some boards will operate at 3.3 volts. So if that happens, like let's say if you want to connect an Arduino Nano to a node MCU, this one operates at 3.3 volts. This one operates at 5 volts. So if we connect this to this board will be destroyed because this 5 volt is higher than the 3.3 volts. So if we connect this 5 volt to this one, this board will get damaged, right? So what we have to do is actually when I say we connect this to this board means serial communication, right? It's like TX, RX, Arduino Nano have 2 pins like TX and RX, and Node MC also have TX and RX. You have to connect these pins to communicate between each others, right? So the voltage levels are different. Now we have to find a way to convert these voltages to matching state. So we will use a logic level like voltage shifter. Yeah, we call it level shifter, right? So logic level shifter will do like 5 volt to 3.3 and 3.3 volts to 5 volt. Okay. That's what level shifters do. You will have to use this if you want to communicate between different boards that use different voltages. Right. Now, if we have look at the signals, this here is high, this 5 volts. This here logic level 0, like turn off, and 0, like so.
Sally, can I ask something?
Yeah.
So logic level
Okay.
voltage.
Another one thing I forget to mention that you can you can achieve this by using a level shifter like this. This is the recommended way. Also, there's another way called resistor divider network. You can use something like this to achieve this same thing, but this is not recommended. Okay, right.
Yeah. Can I ask another question? Why did you say it's not recommended?
Yeah.
Why did you say it's the resistor method is not recommended? Why?
This is like resistors. These are like drop voltages using resistance, right? This is like only can deliver a few milliamperes. In here, this board use like MOSFETs or transistors. They can provide more current, and the way these are arranged, if you look at the circuit, you will see that it's a little advanced than this, right? It's like more reliable. That the arrangement is more reliable than this. The resistors you buy from the store, they have like tolerance, right? That tolerance means that you can't just have 3.3 volts. Maybe they differ like 3 volts, maybe 2.7. They depend on the resistors, right? In this ones, they don't like vary like that. If they say its output is 3.3, then you will get 3.3, like so. This is reliable, not like this, but it's okay to use some points, but this is the recommended way. Yeah.
Awesome. And the original question I was going to ask is this like a buck converter? Oh no.
No, this is not like a buck converter. This actually is like buck converter is like it's actually buck converter is generating a PWM signal and chopping off some part of the voltage signal, right? In here we have like there's a transistor like this. This one is connected to 5 volt or something. Then when this one is get some signal from here, then you will have 5 volts from here. There's no PWM frequency inside this one here. Okay, this
Nice.
one acts nicely differently than this one. Yeah.
Awesome. Thank you.
Okay, right. Okay, now we have come to the variables. The variables are like different kind of baskets, like different shapes, right? Like say integer is like something like, let's say something like this. Char is like something like this. So only so integer type only like excuse me. Okay, right now we have the idea that each and every variable is different from each other, right? They like contains different shapes, right? This is like something like this, like so, right? Float is something like this. Let's say these are just examples. These are not like they don't have actually like shapes like this. Okay, I just trying to explain this. So if you want to put some integer values, you will have to have something called integer variable. Like that, you have a shape like this. You can put that inside this, right? So this shape match this. So now if you have a char like this, you can put that inside this, like so, right? Variables are like so. So mostly used variables are the int. These int stand for integer, so like in maths, right? In maths, integers like numbers 1, 2, 3, like 1,000, like so. Char holds a character like A, B, C. A character. It's like character. Float numbers means that they contains decimal points. Doubles also contain decimal points. Double is more precise than float. It means this can have more decimal points. Unsigned int hold integers stores positive values only. It means that you can't store negative values inside this unsigned int. Like in long, we hold very long integer numbers. Then unsigned long, it hold integer long integer numbers, also positive only, right? Byte is the smallest one after the boolean. It can hold like 255. It means 1 byte equals to 8 bits, right? This is a 1 bit, mean true or false. String holds set of characters like this here, like set of characters is like chained together, right? This is a string. Also that you can convert these integers into characters, floats, doubles, and that is called casting. You can cast variables to another type, right? This is called casting. Okay, that's about variables, and that's it about Arduino. This just the basics, right? They are taught to learn about these platforms, right? Yeah. We'll see more about these things in a practical session, right? I think that's it for today.
Yeah, absolutely. Saliya, thanks a lot for sharing your ideas
Yeah.
and wisdom. And as you said, this is our second session, and for the third and so on, we are planning to go for more experimental, more hands-on, and as you said, maybe bring an oscilloscope,
Yeah.
like for real. I think that's the best way to learn.
Yeah.
Okay, and so let's conclude this session right now, and we'll continue from next session onwards. So thank you again for your valuable time.